We're parents, teachers, and educators, and like you, we're passionate about restoring our culture for Christ. This is Veritas Vox, the voice of classical Christian education.
Hello and welcome again to another episode of Veritas Vox, the voice of classical Christian education. Today, and for the third time, we have Dr. Calvin Beisner with us as our guest. Welcome, Calvin.
Marlon, it's great to be with you again. Thank you so much.
I am really excited. When you first mentioned this to me, my ears perked up because I wanted to hear more. The topic that we're going to talk about is how classical Christian education can rescue science. That begs all kinds of questions for a guy like me. And so, but the first one maybe is a little bit pedantic here. Why does science need rescuing?
Well, that's a great question. Basically, because it's running lickety split away from its roots in classical Christian worldview. It's losing its foundation. The historian Rodney Stark, citing 12 different scholarly studies on the history and philosophy of science, wrote in his book, The Victory of Reason, real science arose only once in Europe. And philosopher Nancy Pearcey and biochemist Charles Thaxton, in their wonderful book, The Soul of Science, wrote, "The type of thinking known today as scientific, with its emphasis upon experiment and mathematical formulation, arose in one culture, Western Europe, and in no other." And I add something chronological to that, not just geographic, but also chronological. It arose in medieval Europe. No other time, no other place. And why is that? It's because medieval
You're
Europe
asking my question.
because medieval Europe was thoroughly informed, certainly at least anyway, at the level of formal education, by a biblical worldview that said that a rational God designed an orderly universe and brought it into being by his word and created human beings in his image to understand and then subdue and rule that orderly world for his glory and as his servants. Take away the rational God, the orderly design of the world, and man in God's image to understand and to rule that world, and you have no basis for science. Period.
Unpack what has been the alternative. I was benefited as I read some of the things you gave me to read for this by understanding what the alternative to that is.
Well, the two chief alternatives are, one, a worldview of materialism. Matter and energy and motion is all that exists. And there you have no mind, you have no purpose, you have no design whatsoever. What that means is that there is no such thing as reasoning. And if there's no such thing as reasoning, then you can't have science. C.S. Lewis, in his wonderful book, Miracles, the chapter titled The Problem of Naturalism, says, in essence, and I'm paraphrasing here, the problem of naturalism is that naturalism is the argument that there is no such thing as argument. It's self-refuting. So that's the problem with materialism. The other alternative, the opposite direction, is going to be either pantheism or panentheism or spiritism, animism. In all of those, we lose the creator-creature distinction. In pantheism, God is the universe. In panentheism, God is to the universe as the soul is to the body. In animism or spiritism, there are lots of little gods, spirits that inhabit rocks and trees and rivers and mountains and so on. And in all of these, as I said, you lose the creator-creature distinction, as you do, by the way, also in materialism. There's no creator. There's just the matter and energy and motion. But having lost that creator-creature distinction, what the Apostle Paul tells us in Romans chapter 1 becomes applicable. Men then begin to worship and serve the creature instead of the creator, and professing themselves to be wise, they become fools because God gives them over to a reprobate mind. So in pantheism, and animism or spiritism, you have a sort of a mystical view of nature. Nature becomes your God. And therefore, instead of grasping the biblical instruction in Genesis 1:28 to subdue and rule nature, you see yourself as the servant of nature, as a slave to nature. And if that's so, then you have no incentive to figure out how to control nature. My friend Vishal Mangalwadi, he is an Indian Christian philosopher, author of the magnificent book, The Book That Made Your World, all about how the Bible shaped Western civilization. Vishal says, look, if you have a Hindu worldview and your river floods frequently, destroying your homes and flooding your town, you try to pacify the god of the river by making sacrifices. If you are a Christian and you understand that God made this world to be subdued and ruled by mankind, and the river floods, you build dams or levees to pacify not the god of the river, but the river itself.
Yeah.
Those are two totally different understandings of how we relate to nature. And the sad thing is that a great deal of environmentalism today wants us to re-sacralize nature and return to being its slaves instead of doing what God instructs us to do in Genesis 1:28, to be fruitful and multiply and fill the earth and subdue it and have dominion over everything in it.
Yeah. Now this is a bit of a softball for me and for our audience. Um, you've made the point that you think classical Christian education is poised to rescue science.
Yeah.
Why? What's your understanding of classical education such that you would say that while a traditional Christian education, as we define the terms typically today, has not rescued science?
Yeah. Classical Christian education better reflects the education that was dominant under the auspices of the church, and I don't mean a specific denomination. And of course, in fact, in the Middle Ages in Europe, there was basically just one denomination, though there were some small offshoots. But the church, the universities that were founded by various churches and so on, that classical education focused greatly on unpacking what Scripture taught us about the nature of the world around us, as well as about the nature of God and the nature of man. It provided us with a truly Christian worldview. And it drew on some of the insights of earlier classical culture, especially Greek and Roman, but it also recognized that we needed to go beyond those things. For example, because uh, in Greek and Roman thought, say, take for instance Aristotelian thought, uh, all reasoning was to be deductive. And what that meant was that you started out with certain assumptions about the world around you, and then you deduced from those assumptions theories as to how things worked in it. But without a commitment to careful observation of what was really happening, you couldn't test those predictions very well. So we needed to add inductive reasoning to deductive reasoning. And that required that we understand the world out there as a reasonably ordered place where things were going to be predictable because a, a reasoning God made it that way.
Yeah.
So that's a piece of the puzzle there, but there's more to it, really. We could really go into quite a number of different ways that that the classical learning contributed to the development of science. And there, I would draw, for instance, Piercy and Thaxton, in their book, The Soul of Science, offer 10 assumptions without which science cannot develop. And all of these are owed to the biblical worldview learning of the medieval church and its influence on European culture.
The roots of classical ed. Yeah.
Right.
Yeah. So I, it is an interesting thing. I've been involved in the uh, redevelopment, I guess is a good term for it, of classical Christian education now for
Mm-hmm.
more than 30 years. And it's a tough thing
It
to
is.
um, to try and understand that which I wasn't taught, and to then try and introduce it to a generation so that they don't have to suffer the
Yeah.
failures in education that I did. As it relates to science, do you have some thoughts on how people who uh, are like me might help that process?
Yeah.
It's a lot of work to get where you did,
Yeah,
and
it
not
is.
everybody
It
can
is a
do
lot.
that.
It is a lot of work. I would refer again to Piercy and Thaxton's book, The Soul of Science.
Okay.
I think that is just a tremendous help. You might also look to the book Christianity. Let's see, uh, Christianity and the Nature of Science, I believe is the title, by the Christian philosopher. Huh, I've forgotten it. I was the copy editor for that book for its
Okay.
publisher, Baker Bookhouse, back in the 1980s. But it's an excellent book.
Yeah.
Um, you know, we need to grasp what are the assumptions without which science cannot develop and cannot survive.
Yeah.
Okay, so if I can, let me just try to run very, very quickly through
Sure.
those
Please do.
as they come to us from Piercy and Thaxton in their book, The Soul of Science. First of all, nature is real. It's not an illusion, as in Hinduism. If you don't think it's real, you have no real reason to try to study it. Second, nature is good. It's of great value. It's not evil, as in Gnosticism. Gnosticism taught that an evil God created the material world and matter is in and of itself evil, so you don't want to get mixed up with it. Third, nature is merely a creature. It's not a God, which means you're not a pantheist, you're not a panentheist, you're not even an animist. But nature, as merely a creature, can therefore be subject to human rule. If you think of nature as your God, you can't rule it. All you can do is to try to buy it off with sacrifices. Fourth, in nature, events occur in a reliable, predictable fashion because God is trustworthy and dependable, and therefore the creation that he made must likewise be dependable. But if you are a total materialist, everything happened by chance anyway. You can't think that it's going to be predictable. And if you are a pantheist or a panentheist or a spiritist, an animist, well, there are little gods and goddesses, inhabiting things and causing them to do all sorts of things that you wouldn't have expected. You have to think that there's going to be predictability and expectation in how nature works. Fifth, you have to believe in an orderly universe. And that understanding came to be summed up in the concept of natural law. People in pagan cultures see nature as alive and moved by mysterious forces. And because of that, they're not likely to develop the conviction that all natural occurrences are lawful and intelligible. That conviction that nature is intelligible comes only from biblical principles. Even, we can even say that to the materialists, the natural scientists who just reject God, reject everything spiritual. We can come back with Lewis's point from his book Miracles. The problem with naturalism is that it's the argument that there is no such thing as argument. Atoms and molecules don't sit down and have a cup of tea and talk about where they're going after they collide. They just exchange energy and move, right? Sixth, the conviction not only that nature is lawful, but also that those laws can be stated in precise mathematical formulas stems from the biblical teaching that in its essential structure, the universe is precisely what God wants it to be. The historian R.G. Collingwood said, the possibility, I'm quoting here, the possibility of an applied mathematics is an expression in terms of natural science of the Christian belief that nature is the creation of an omnipotent God. If you don't buy that, then you can't do science that depends on mathematical representation of the world around you. Number 7, man is a rational, comprehending observer of nature because man is created in the image of God. The sinologist Joseph Needham, in his book, The Grand Titration, right, says the Chinese never developed modern science, even though, by the way, they developed some interesting technologies early on, long before Europeans did. They never developed modern science because they had no belief either in an intelligible order in nature or in the human ability to decode an order if it existed.
Interesting.
Number 8, nature comes with surprises, not because it is inherently irrational, but because it is the work of a free and personal God who does with it as he pleases.
With a level of
Therefore,
complexity that we can't fully
right,
grasp.
right. So because of that, all the deductions about nature that we make, deduction is Aristotelian thinking, okay, and it's good within its limits, right?
Mhm.
But all the deductions we make about nature must be tested by observation and experiment. Christianity regarded natural law not as forms, capital F, forms inherent within nature, but as divine commands imposed on nature from an outside source, God himself. But God's freedom entailed a nature that required not only deductive inference, but also specific observation to be known by man. Now, that understanding of natural law comes with a price that atheists are not eager to pay. The possibility that God, who imposed the laws of nature from outside nature, can also intervene in the normal working of the laws of nature, meaning miracles are possible. So that's really crucial to scientific understanding. And then number 9 rather, from Piercy and Thaxton, the world is intelligible because it reflects God's rationality. And finally, number 10, the transition from science to technology itself required certain presuppositions about the world. It required a set of beliefs that sanctioned active intervention in natural processes to advance human purposes. To fill and subdue the world, as God instructs us to do, requires a commitment to doing that, and it requires technology in order for us to achieve that. I referred earlier to the Hindus and their response to a flooding river, and Christians and their response. That's really crucial. This is why science as a regular programmatic process of hypothesis, observation, revision of hypothesis, constantly testing, arose only once in all time in only one place, and that was medieval Europe, which bought into this biblical worldview. And by the way, I think there is one Bible verse that really points to the root of science. This is what science is all about. 1 Thessalonians chapter 5, verse 21, test all things, hold fast what is good. That is really what the Nobel Prize winning physicist Richard Feynman called the key to science. You can find a brief video online by just looking up Richard Feynman key to science. And he says, when we want to understand how something in nature works, first we guess. Then on the basis of our guess, we make predictions of what we should see in the real world if our guess is right.
Yeah.
Then we go out and we make the observations in the real world, whether it's out in nature or in the laboratory. That's reality, okay? If our observations contradict our predictions, then our hypothesis, our guess, is wrong. And it doesn't matter how smart we are or how beautiful our guess is, I would add, or how many people agree with our guess. If the observations contradict the predictions, then the guess is wrong. It is precisely the move away from that I see as the very rapid and slippery path into irrationality that's happening in more and more of our sciences, particularly in climate science, as people confuse the output of computer models with the real world, and then they lose the capacity to test and correct those models by comparing observations with predictions.
Unpack that a little bit. What I've written down here in preparation for this was the idea that a computer model output is not data and it
Yeah,
must be tested by empirical observation.
yeah,
Help us understand where we have gone wrong as climate
yeah.
scientists.
Well, there's an absolutely fascinating, very long article in the December 2005 issue of Social Studies of Science. That's a refereed journal in the
Okay.
sociology of science. It's by Mariana Lawson, and it's titled Seductive Simulations. And when I first read this about, oh goodness, 15 years ago, a little longer than that, I was floored. Mariana Lawson, who's a sociologist of science and who is committed to post-normal science, a topic we might discuss if we have time, and who is herself committed to, or at least at the time, was committed to the notion of catastrophic man-made global warming. She spent months and months studying the computer model climate scientists at the National Center for Atmospheric Research in Boulder, Colorado. She was studying them as a sociologist of science. And she had one fundamental question in her mind throughout all of this study. She had lots of other questions, but they all were designed to bring out an answer to this question. Do these scientists consciously remember as they do their work that their computer models and the output of those computer models are not the real world? And so she would ask a question, for instance, about what happens if the concentration of CO2 in the atmosphere rises by such and such a percent. And the modeler will say, well, the ocean does so and so, the lower part of the atmosphere does such and such, the upper part of the atmosphere reacts this way. We have these changes in temperature and cloudiness and precipitation and so on. And she says, you said the oceans. Now, is that the real ocean out there, or is that the ocean in your computer model? And she would get these very nervous responses as the scientists would realize, oh, I said the ocean and I meant what my computer model is doing. And she concluded her article basically with, these guys can't tell the difference. They don't
Wow.
remember that their models are not the real world. Now, I have a hypothesis of an explanation of this. I've never been able to take the time to really study it through, but prior to the 1970s, the vast majority of people studying to become scientists did whatever modeling they did by hand on paper. So their models were
The
quite simple.
processors weren't with us yet.
Yeah. And then they went out into the real world. They did most of their work out there in nature, in the real world, or in the laboratory doing experiments. But from the late 1970s onward, computer time got cheaper and cheaper and cheaper. So it became much less expensive and much quicker and easier to do computer models instead of real world observation. Now, the younger scientists who grew up doing this computer stuff, I see them as very much like young people who are so embedded in their computer games in
They can't tell the
Dungeons,
difference in that reality.
Dragons, whatever,
Yeah.
things like this. They can't, they have a hard time telling the difference between that and the real world. And actually, there have been in-depth psychological studies on that.
Right.
There's some real psychological problems that come from it. So, yeah, what we have is this incapacity on the part of many climate scientists to distinguish model output from real world. And so then they'll say, well, if we add so much CO2 to the atmosphere, this is how much warming will happen. And they will treat that output as if it were data. It's not, it's
Yeah.
hypothesis. And the reality is that the vast majority of all the climate models that are being run for the UN Intergovernmental Panel on Climate Change and various other organizations, they all assume, as one assumption, that clouds respond to a little change in temperature at the surface by magnifying that change. In other words, that clouds are a positive feedback. If you get a little warming at the surface, clouds will change so as to increase that warming. You get some cooling, they'll change so as to increase that cooling, right? But Dr. Roy Spencer, who's a climate scientist at the University of Alabama in Huntsville and is also a board member and senior fellow of the Cornwall Alliance, Roy, in meditating on Genesis telling us that everything God made was very good, inferred from that that it wasn't likely that Earth's climate system would be dominated by positive feedbacks. And so he then thought, what if the clouds actually are negative feedbacks? But he had to make some way of testing that. So he used NASA's climate observation satellites, and he and his partner John Christie there are largely in charge of that for NASA and have won awards from NASA for their work. He used those satellites to actually test. And what he discovered was that clouds are not a positive feedback, they're a negative feedback. They limit the warming from added CO2 in the atmosphere. That's the opposite of what the models say. And the shocking thing is that almost all the models still treat clouds as positive instead of negative feedbacks because the modelers are more committed to their theory than they are to the real world observation.
Finding the truth, yeah.
Yeah.
You used a term that is not a term that I know to be common knowledge as a way of defining kind of where we are. You called it post-normal science. What is that?
Yeah, right. Well, post-normal science, a very simple way to put it would be to say that post-normal science is postmodernism applied to the sciences.
Okay.
Postmodernism
Yeah.
is basically a literary theory, and it finds meaning not in the text as intended by the author, but in the readers of the text. And then it moves into personal, lived experience as how you interpret a text and so on. You can sort of think of post-normal science as doing something similar to that. Normal science performs in the way that I described when I referred to Richard Feynman and his key to science. We have a guess as to how something in the world works. We make predictions based on that guess of what we should see. Then we compare observations with predictions. And if the observations contradict the predictions, the guess is wrong. And that's basic scientific method. Post-normal science instead works in a very different way. Um, it 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 takes the persons doing it and involves them and their values and their commitments and their agendas, and then it sees the scientific endeavor as basically trying to serve those agendas. Science becomes a matter of power plays and of justifying various agendas rather than of uh, personally non-committed investigation of what's actually out there in the real world.
Very helpful. Well, I couldn't agree more that classical Christian education is ideally poised to be part of the solution for rescuing science from some of the silliness that we see in lots of different areas. And I hope and I expect that what you're doing will help motivate the classical educators to help bring that about. Thank you very much for your work. Thank you for all of your time in these 3 episodes. This has been wonderful, and it has kept my head spinning the entire time. Thanks.
Yeah. Well, thank you. I might add, by the way, that we have a booklet at Cornwall Alliance in our online store called What Can Theology Say to Science About Climate Change? And it goes through much of what we've discussed and other things as well. And for listeners to your podcast, when they make a donation of any size to the Cornwall Alliance and mention that they heard of this on your program, Veritas Vox, we would be glad to send them a free copy of that. All they have to do is to go
Wonderful.
to cornwallalliance.org. That's cornwallalliance.org/give, make a donation of any size, and ask for what can theology say to science about climate change. And we'll be happy to send them a free copy.
Thank you. Thank you very much. And folks, thank you for joining us on another episode of Veritas Vox, the voice of classical Christian education. Dr. Beisner, this has been great.
Thank you very much, Marlon. It has been a lot of fun. God
Thank you.
bless.